Welcome back. Thanks for joining me again. In this segment video, I'm going to talk about how to, or the process of taking a complex number in polar form and raising it to a particular power. This is not difficult, which I love. For once, something that's not all that difficult. We're seeing a complex number z, which is, excuse me, being represented in polar form, r cosine theta plus I sine theta. We're going to take that z value and we're going to raise it to the nth power. So here you're seeing z to the n. And in the previous video, when we multiplied complex numbers, we multiplied their radii. But in this case, because we're taking a complex number and raising it to a power, it's the same radius being multiplied by itself n times. So that might be r times r times r times r. How many times are we doing that? N times. So if you follow me over here to the right, you're seeing r to the nth power. In the previous video, we also said that when we're multiplying complex numbers, you have to add the theta values. Well, here, this theta value, or this complex number, is being raised to the nth power, which means we have to add that theta value to itself n times. So theta plus theta plus theta n times. Hi, Loudmouth. Are you joining us? Come on, come say hi. Instead of writing theta plus theta plus theta, we can write n theta. There she is. Queen of the... You're so indecisive. Where are you going? I never know. She's dangerous. All right, so that is the format for... Hello. If I erase too many things, if I hit the back button too many times, it takes me all the way back to the previous thing that I wrote. So if we're taking a complex number and raising it to the nth power, we take the radius to the nth power and multiply the theta value by n. I promise I'm not getting paid by the minute. These videos, I can't help myself but to elaborate. So here the r value is equal to 1/2. The theta value is pi over 10. And so we're going to take, oh, and here's the n value is 5. So we'll take the 1/2, raise it to the 5th power. We'll multiply that by cosine of 5 times the theta value, which is pi over 10, plus I times the sine of n times theta, which is still pi over 10. 1/2 to the 5th power, as I'm sure you know off the top of your head, is equal to 1 over 32, times the cosine of 5 pi over 10, which reduces to pi over 2, plus I times the sine of pi over 2. And there is your resulting complex number expressed in polar form. The 1 over 32 I arrived at by taking the numerator and raising it to the 5th power. So 1 to the 5th power is equal to 1, and the denominator to the 5th power, 2 to the 5th, is equal to 32. Yes, you are allowed to do that. It looks sort of like the distributive property of exponenting. Don't think of it that way. Think of it as 1/2 times 1/2 times 1/2 times 1/2 times 1/2. And when you multiply fractions, you multiply the numerators and then separately multiply the denominators. So all the 1's multiply together to a 1, and all the 2's multiply together to a 32. And that's your 1 over 32. So that's raising a complex number to a particular power. And I'm going to stop there. And I'm going to see you back here in a blink. All you have to do is click on that little box below me, and you will arrive right back here so we can have a conversation about taking nth roots of complex numbers using DeMoivre's theorem. See you in a second.